Okay, this is Target 90 using Trig to solve real-world problems. So we have an electrician who leans a 13-foot ladder against a house. So let's draw the house. There's the house. Okay. And there's a ladder that's leaning up against the house. And we know that this ladder, I'll go ahead and make it look ladder-like. There's the ladder. We know that that ladder is 13 feet. Okay? And we know the base of the ladder, so right here, that's the base of the ladder. And we know that that is 4 feet from the house. So that's right here. This right here is 4 feet. And we want to know how high up the house the ladder reaches. So we're looking for this distance right here. Okay? So again, we are looking for a side. So when you're looking for a side, the first thing you have to ask yourself is, can I do the Pythagorean theorem? This is a right triangle and we have two sides. So since it's a right triangle and we have two sides, we can do the Pythagorean theorem to find this missing side. So remember, the Pythagorean theorem is leg squared plus leg squared equals the hypotenuse squared. The hypotenuse is the one across from the 90-degree angle, so that's 13. So that goes here. And then the two legs are x and 4. So x squared plus 16 equals 169. And then I'm going to subtract 16. And I get x squared equals 169 minus 16. I have to get my calculator out. Actually, I don't. I can do that. It's 153. But I'm going to go ahead and get my calculator out because I have to find the square root anyway. So 169 minus 16 is 153. Double checked. And then square root. And I get x is the square root of 153. So on your calculator, find the square root of 153. You get 12.36 or 12.4. So 12.36, but it says to the nearest foot, so that means a whole foot. Okay, so this 3 does nothing to the 12, so it would be 12 feet. So the ladder is right now 12 feet up the building. Okay? Number 2. There's a lamp on the street. So here's the lamp. It's got all this light shining through it, and it's a post, right? So it's a lamp post, there's a lamp on top of it. And there's a sun behind it, and it's casting a shadow on this. So right here, this is the shadow. And we know that the lamp is 13 feet tall. And we know that the angle of elevation from the lamppost to the sun, or I'm sorry, from the ground to the sun, that's this angle right here, is 57 degrees. And we want to know how long the shadow is, so we need to know what that is. And again, this is a right triangle. So again, we're looking for a missing side. So the first thing I have to ask myself when I'm looking for a missing side is, when I'm looking for a missing side, I have to ask myself if I can use the Pythagorean theorem. Now, I can use the Pythagorean theorem if it's a right triangle, this is, and if I have two sides. The problem is I only have one side. I only have 13. I don't know what this side is or this side, so I can't use the Pythagorean theorem, which means I have to use trig. So, SOHCAHTOA. Okay. Oh, I thought I wasn't recording for a second. Okay, so let's put a dot here, because that's the angle I give you. Again, you have to put the dot at the angle they give you. The angle they give us is 57. The side across from that right there is the opposite side. This side right here is the hypotenuse, and this is the adjacent. Okay, so I need to use the side that they give us, which is 13, and the side that I'm trying to find, this x here, or the shadow, which is the adjacent. So which one uses opposite and adjacent? And again, it's tangent. So the rule is the tangent of the angle is equal to the opposite over the adjacent. So the tangent of the angle, well, the angle is this one with the degree here, 57 degrees. And that equals the opposite, which is 13, over the adjacent, which is x. I'm going to put this over 1, and I'm going to cross multiply. And when I cross multiply, I'm going to do this in different colors so it doesn't bleed in with the rest of this. I get 1 times 13, which is 13. And I get x times tangent 57. So I need to get x by itself, so I'm going to have to divide both sides by the tangent of 57. So I'm going to have to go over here because I'm running out of room. X is equal to 13 divided by the tangent of 57. So x is equal to, now I'm going to plug this in my calculator, and again I have to make sure that my calculator is in degree mode, not in radian mode. And I'm going to do 13 divided by the tangent of 57. So 13 divided by tangent 57. Make sure I'm in degree. I am, and I get 8.4. So x is 8.4. So my shadow is 8.4 feet. Okay, number 3. We need to find the angle of elevation. So an angle of elevation is the angle looking up. So from the ground, so from here to the top of the tree, to here. This is a line of sight. So this right here is the angle of elevation, and that's what we're looking for. So we'll call it x. And this is a right triangle. Again, when I'm finding this is a right angle, when I'm trying to find the missing angle, not side, the first question I ask myself is, can I use a triangle sum theorem? And I cannot. I only know one angle. I'm sorry, just this one right here, 90 degrees. I don't know this one, so I can't add them and subtract from 180 to find this one. So I have to use trig. But again, when you're using trig, to find an angle, you have to use the inverse trig functions, right? And again, now we have to label what's across from the x is opposite, and this is the hypotenuse, and this is the adjacent. So now we need to put some of the information that they gave us into the picture. It tells me that the tree is 47 yards tall. And I don't know about you, but that seemed kind of tall to me, so I was looking that up. A yard is 3 feet, and so 3 times 47 would be what, 120 and 21, so 141 feet. And then I was wondering, that's kind of tall for a tree. Is that even real? And I looked it up, and the giant redwoods are up to 400 feet tall, so this is not an unreasonable assumption. Okay, and it casts a shadow that's 33 yards long. So again, 33 right here. And we're looking for the angle. So I have to use the two sides they gave me. They gave me the 33, which is the adjacent, and the 47, which is the opposite. So we add O and A. And according to SOHCAHTOA, O and A is tangent. But I'm finding an angle, so instead of using tangent, I have to use the inverse tangent function. So that formula is the angle is equal to the inverse tangent of the opposite over the adjacent. So my angle, which is x, is equal to the inverse tangent of the opposite, which is 47, over the adjacent, which is 33. So now I just plug this into the calculator. So I hit on my calculator, and I'm going to say second tangent, and then I'm going to say 47 over 33. and I get 54.92. And it says run to the nearest degree, so that means whole degree. So that 9 is going to make that 4 or 5, so it's going to be 55 degrees. So the angle of elevation is 55 degrees. Okay, number 4. You go to the park on a windy day to fly a kite. You have released 68 feet of string, so this is 68. You hold a kite at an angle of 51 degrees, so this angle right here is 51 degrees, 4 feet above the ground. So your hand is not on the ground, your hand is up in the air, and it's 4 feet off the ground. So I know the distance from the ground to your foot, or to your hand right here, is 4 feet. Okay, and I'm looking for how high is the kite in the air. So that's this. How high is the kite right here? Right? And to find that, I need to find this. But that's not going to give me the height of the kite. It's just going to give me from here to here. But remember, the kite is also this much off the ground. So that 4 feet off the ground. So when I find this x, I'm going to have to add 4 to it to get exactly how tall the kite is, right? Alright, so I have to stand at the angle that they give us, which is 51. I'm finding a side. So if I'm finding a side, the first thing I ask myself is, can I use the Pythagorean theorem? And you can use the Pythagorean theorem if it's a right triangle. And this is certainly a right triangle. And if you're given 2 sides, but I'm only given the 68. I don't know this side, and I don't know this side. So I have to use trig, or SOHCAHTOA. Okay. So x is the opposite. If I'm standing at 51. 14 is the hypotenuse. And then this distance right here is the adjacent. Now I have to use the side that they give us, so that's the hypotenuse. And I also have to use the one I'm trying to find, which is x, which is the opposite. So which one uses opposite and hypotenuse? Well, it's sine. So the rule for sides, it's not the inverse. I use the regular trig functions, not the inverse trig function. So I say the sine of the angle is equal to the opposite over the hypotenuse. So the sine of the angle, well, the angle is 51, and that equals the opposite, which is x, over the hypotenuse, which is 68. I'm going to put this over 1, and I'm going to cross multiply. And I get x equals 68 sine 51. And I'm going to plug that into my calculator. So 68 sine 51. Sine of 51, and again make sure your calculator is in degree mode, and it's 52.8. Okay, so I'm going to say x is 52.8. It doesn't say what to round it to, so I'm going to leave it as 52.8. So 52.8, but that's just this. Now how high is the kite? I'm going to take that 52.8 and add the 4 feet that my hand is off the ground, and I get 62.8 feet high in the air. Only I made a mistake. You guys are probably saying, hey, Mrs. Gordon, no, 52.8 plus 4 is not 62.8. Instead, I can't erase it, so I have to cross it out. 52.8 plus 4 is 56.8 feet off the ground. So the correct answer is 56.8 feet off the ground, not 52. Problems you have to try on your own. You have to show them to your geometry teacher, your geometry support teacher, or a math lab teacher. Okay, so here's problem number 1, the electrician and the ladder problem. Number 2 is the lamppost. Number 3 is the tree problem. And 4 is the kite problem. Okay, Good luck.